students, now we shall look at one more numerical on real gases. Determine the mass of nitrogen contained in a 30 meter cube vessel at 20 megapascal and 200 Kelvin by using A. the ideal gas equation of state and B. the generalized compressibility chart. So there is a vessel with a volume of 30 meter cube. In that nitrogen is stored. Nitrogen is normally stored under pressure. So this is at 20 megapascal. If you want to convert into kilopascal, you have to multiply with 1000. Okay, and the temperature is given as 200 Kelvin. So it is like sub-zero temperature. Okay. Now ideal gas law is PV is equal to MRT. Now we have to find mass. To find out mass, what I will do? M is equal to PV by RT. Okay. M is equal to PV by RT. So substituting the value, M is equal to P is 20 megapascal. So 20 into 1000, that is 20,000. And volume is 30 meter cube. Okay. P into V हो गया, divided by R is 8.3143 divided by 28. Nitrogen is N2. N2 means 14 into 2 is 28. Okay. And T is 200 Kelvin they are given. So they are given pressure, they are given volume, they are given the temperature. You know the molecular weight of nitrogen as 28. So you found out the mass as 10103 kilograms. Okay. This is using an ideal gas equation with the relation PV is equal to MRT direct. Now we have to use compressibility chart. Okay. Now for compressibility chart, what they are given? Now if you look at this table for critical pressure and critical temperature. Now if you look at the third row, nitrogen N2, what is given here. So the critical temperature is 126 Kelvin and critical pressure is 3.398 megapascal. Okay. So and the critical volume is also given as 8.99. That is molar specific volume. So we will use these relations. Like for nitrogen, the critical properties we have seen as 126 Kelvin is the critical temperature and 3.4 is the critical pressure. So this we will use in the for now we have seen that P is critical pressure, PC is 3.4 megapascal, TC is 126 Kelvin. So reduced pressure is actual pressure divided by critical pressure. So actual pressure is given as 20 megapascal, that is 20,000 kilopascal, divided by this critical pressure is 3.4 megapascal, that is 3,400 kilopascal. So you get reduced pressure as 5.88, and then reduced temperature is nothing but actual temperature, that is 200 Kelvin, divided by the critical temperature, that is 126 Kelvin. So you get TR is equal to 1.598. So now you got what you got. Now what we have got? Reduced pressure we have got as 5.88. PR is 5.88, or you can say 6. It is very close to 6. And then TR is 1.585 or 1.5. Okay. So 1.5 TR and 6 PR, we will find out the value of Z from the chart. So now you look at this chart here. Now you look at the chart. Now this bottom is PR, reduced pressure. So reduced pressure he has given us 6. So this line is the reduced pressure 6. Okay. And TR was 1.5. TR was 1.5. So TR 1, 1.1, 1.2, 1.3, 1.5. So this line is the reduced TR of 1.5. So this is intersecting at this point. At this point, what I will do? I will take the left like this. So this will give the Z value. So what I have done first is PR, reduced pressure. This is number 1. Okay. Then I found out TR. TR lines are given like this. So this was a TR line. This is number 2. The point of intersection, I have taken it to the left and I got the value of Z. This way you find out the value of Z. So you can see from the compressibility chart, we got the value of Z as 0.902. In chart you will not get 0.902, you will get only 0.9. Okay, because they are not accurate to that 3 digits and all. Now we know that PV is equal to ZRT. So V is equal to ZRT divided by P. So Z we have found out as 0.902. R is 8.3143 divided by 28. Molecular weight of nitrogen is 28. Temperature is given as 200 Kelvin. Divided by pressure is given as 20 megapascal or 20,000 kilopascal. So V is 0.002677 meter cube per kg. Okay, and if I want to find out the mass, now for the general compressibility chart, the mass we will find out. Mass is equal to volume divided by specific volume. Volume is 30 meter cube. Specific volume is, we have found out 0.002677. We found that the mass is 11,206 kg. Now you can see in these two solutions what we have found out. The mass of the gas in a 30 meter cube cylinder was 10,103 kgs. Okay, 10,103 kgs if you calculate using ideal gas equation. But in real gas, when you are using the compressibility chart, we have found out the critical pressure and critical temperature based on the chart, critical parameters which are given in the chart, and from that we found out the reduced properties, and using the reduced properties PR and TR we found out the value of Z, and substituting the value of Z in PV is equal to ZRT, we found out the specific volume, and from the specific volume you found out the mass. Mass is equal to total volume divided by specific volume. So you found here that the mass is not 10,103, but it is more. It is more than 1,100 kgs more. It is 11,206 kg. So this is a actual difference between ideal gas as well as real gas. So in real life we need to consider the real gas equations, and here we are in this problem we have used the compressibility chart to find out the mass. Thank you.